Hello, and thank you for joining me today as we begin our discussion on Unit 2. We're going to start talking about matter. So this unit, we're going to talk about classifying matter, changes to matter, properties of matter, and then we'll expand from there here this semester. So to start with, we're going to talk about matter classification. So at the end of this video, my goal for you is to be able to define what matter is and where you can find it. So give me examples. You'll be able to classify matter as either an element, a compound, a solution, or a mixture, based on what you know about the substance and these terms. Be able to differentiate, tell me the differences between compounds and molecules, and last but not least, to understand what a chemical formula indicates about a substance. So let's get rolling. First off, matter is anything that has mass and takes up space. In essence, you matter. All matter can be classified as either an element, a compound, or a mixture, and we'll get into these on the next slide. So we have these things called pure substances. Pure substances are any matter that has a fixed composition and definite properties. And so of those things that we listed on the previous slide, elements, compounds, and mixtures, your elements and your compounds are both examples of pure substances. So an element is a substance that cannot be broken down into simpler substances by chemical means. This is as simple as it gets. And when we say simpler substances, these all have the same number of protons. We'll talk about this later on in this semester. But if I change the number of protons an atom has, I change that identity. So I change it from, say, oxygen to nitrogen, or from nitrogen to carbon. That I'm changing the substance. I no longer have oxygen anymore. I have something different. So that makes it a new substance. That's an element. A compound. A compound is a substance with atoms of two or more elements chemically bound together, chemically combined. So compounds have atoms of two or more elements chemically combined. If I'm talking molecules, these two words are very close, extremely close. So molecules are any two atoms chemically bonded together. They can be the same atom, they can be different atoms. So up here I have a gold coin and a copper penny. So these are examples of pure substances, gold and copper. If I come to the bottom, I'm looking at compounds. I have water. Water is made of one oxygen and two hydrogen atoms bound together. So I have atoms from two different elements bonded together. Ammonia is one nitrogen and three hydrogens. So again, two different elements chemically bonded together. Carbon dioxide has one carbon and two oxygens, two different atoms bound together. And then hydrogen peroxide is two oxygens and two hydrogens. So two different elements chemically bound together. If I'm looking at molecules, I would call these atoms, I'm not going about monatomic molecules, diatomic, meaning I have two atoms of the same substance. So I have two hydrogens here. Because hydrogen is the same substance, it's not a compound, it is a molecule. Oxygen, same thing, two oxygens, chlorine, two of those. I can have water, so water is a molecule. Molecules are compounds, compounds are not molecules. Hold on. Compounds are molecules, molecules are not compounds. Sorry, make sure I get that right. And phosphorus has multiple bound together, all the same. We're going to review this a whole bunch and make sure that we practice it. Symbols and formulas. If we're talking about elements, elements are represented on the periodic table by one or two letter symbols. The first letter in each case is always capital. If it's got a second letter, that letter is lowercase. So for example, we have iodine is number 53, capital I. Lutetium is number 71, capital L, lowercase u. Vanadium's got a capital V, uranium's capital U, oxygen capital O, yttrium capital Y. So first letter is always capital, second letter, if there is one, is always lowercase. And then we're going to put these into, we're going to group these together, we're going to create what's called a chemical formula. And we use these to represent our compounds. For example, water. This is a chemical formula for water. This shows how many atoms of each element are in one unit of the substance. So in this case, I have two hydrogens and one oxygen in one molecule. 2 hydrogen and 1 oxygen in one molecule. So the number following the chemical symbol is called a subscript. So this 2 is a subscript. It shows the number of atoms of that element in the substance. Number of atoms in a molecule. The number in front of a chemical formula, so if I can put a 3 here, or I can put a 3 here, this number is called a coefficient. And this shows me the number of molecules in a reaction. We'll talk more about that later on when we start balancing equations. But that is a chemical formula. So really quick, I want to know what is matter. So pause the video. But what is matter? What are the 3 ways matter can be classified? And how are element symbols written? And then I want to know, what do chemical formulas tell us about a substance? After you've answered those, hit play. We'll finish this section. So welcome back. We've talked about pure substances being compounds and elements. Our other way to classify matter is by a mixture. So mixtures are 2 or more substances that are physically bound together, physically combined. For example, I have trail mix over here, and I have milk and I have Kool-Aid. And so these are different, but they are all physically combined. So if we look at this, we have 2 types of mixtures. One is called a homogeneous mixture. We call these solutions, so these 2 words mean the same thing. This is a mixture containing 2 or more gas, liquid, or solid substances that are blended evenly throughout, being they're really hard to separate, or impossible to separate. They're uniform all the way through. A heterogeneous mixture, so a lot of times we've heard the word homosexuals being same sex, attracted to each other. So homogeneous means same composition all the way through. Heterogeneous, so heterosexual, male, female. Heterogeneous means there's different appearances all the way through. So this is a mixture in which different materials can be distinguished easily. For example, a pizza makes a great heterogeneous mixture. A whole bunch of things bound together, physically put together. You can take them apart, but they look different. Here's chocolate milk. And so milk, different liquids can be shown to have a mixture, shown as a mixture. We have a couple other terms, and so there are some mixtures that can mix infinitely and others that don't mix at all. So we have this term miscible, means infinitely soluble. So for example, I can mix water and ethyl alcohol. I can have as much ethyl alcohol or as much water as I want to, and it'll always dissolve. One becomes a solute, one becomes a solvent. We'll talk about that later, not a big deal. Or I have some things that are immiscible, meaning they don't mix at all. So water and octane. Water sits down below, octane sits above. Water and octyl alcohol are immiscible. Water's on bottom, the alcohol's on top. So oil's the same way. Water on bottom, oil on top. So that's immiscible. So miscible is infinitely soluble. Immiscible can't be mixed at all. Here are your last set of review questions. I want to know, what is matter? How are compounds and elements different? What are mixtures? What are the 2 kinds of mixtures? And how are they different? What does miscible mean? What about immiscible? Pause the video, answer the questions, and I will see you when you return. If you have any questions prior to that, please let me know. Shoot me an email, stop in to see me. I'd be happy to talk through it with you, and we will continue on from here. For now, enjoy the rest of your day, and I will see you next time.